Welcome to Module 6, Lesson 24, Surface Area, Part 2, we'll say. My original intention was to put 23 and 24 together, but I decided to separate them as they would have been too long as one unit. Okay, so you're going to see a lot of similar problems to Lesson 23. My advice is to just make your way through this. You may see some areas where you think, wow, this is easy, I've done this, done lots of things like this, but just keep plugging along through, because there are a few questions that are different, or some things you might not have seen before. Towards the end of the lesson, though, they're going to be a repeat of a few exercises, so I'm just going to refer you back to the ones that came earlier in this lesson, and you'll see what I mean when I get there. So anyway, I'm just going to try to do this as efficiently as possible. Okay, so let's begin. And here we go. Determine the area of the image. Okay, so I'm going to have you struggle with that, if you please, and then come on back and we'll solve it together. Alrighty, so here we go. I started with these top pieces, or these these large flat pieces, and I see 4 of those. I'm going to disregard the fact that there's this little area here that is actually not exposed there, and also underneath there somewhere. Okay, I'm just going to disregard that for now. So I'm just going to take care of all of the positive, or all of the potential surface area, let's say. Okay, so that's going to be 4 times 12 times 12, okay, because those are 12 by 12 squares, and that is going to give us a total of 576 square inches for those 4 surfaces, okay? Alright, so next we have a whole bunch of those, okay, as these are squares we're talking about. Quite convenient in the fact that all of these are going to be the same size, okay, same dimensions. Alright, so we have 8 different faces that are all 3 by 12. Therefore we have 8 times 12 times 3, which gives us a total of 288 square inches. And then we have, again, multiple similar sides. We have 4 of those 8 by 4 faces, and that comes out to 128 square inches. Okay, so that's all of our positive. It's all our positive surface area. Okay, so now we have 2 holes we need to contend with. Okay, because those are not, there's not exposed surface there. Okay, holes is actually kind of metaphoric. It's not actually true. It's not a hole necessarily. It's actually where surface is actually blocked off. Okay, and those 2 holes, or quote-unquote holes, happen to be 4 by 4 pieces that are not exposed. Therefore, let's paint those in red here. So 2 of those 4 by 4 sections gives us a total of 32 square inches of let's call it non-surface area. Okay. All right. So if we go ahead and add up all the positive, we get 992 square inches. Subtract away that negative, and we end up with 960 square inches of surface area on that image. So if you were to paint it, you would need enough paint to cover 960 square inches. Okay, and this one looks really simple, and it is, but it leads to a more interesting problem that follows it. Okay, so here we go. We're going to determine the surface area of the cube. I'm going to go ahead and pause. You pause as well. Do that yourself and come on back. Should not take you long. Oops. Oh, sorry. Let me stop. All right. Well, sorry about that. I apologize. Yes, I hit the expose all button, which I did not want to do. So let's go ahead and do this, determine our surface area of our cube, okay? Which happens to be really, really super duper, is that we have 6 equal sides, okay, or faces. They're all the same. So they're all 12 by 12, which is real nice because it is a cube. We have 6 12 by 12s, which is going to give us a total of 864 square inches of surface area in that cube, okay? What is more interesting, though, of course, is this next problem here. A square hole with a side length of 4 inches is drilled through the cube. Now, drilling a square is a bit of a task, I would say. Usually drill round holes, so we could say jigsawed might be a more apt term, I guess. So now you're going to go ahead and determine the new surface area. Okay, you're going to see you're going to lose some, as you can tell, which is the most obvious, but you're also, give you a little hint, you're also going to gain some surface area. Okay, so I want to have you struggle with that a bit, and come on back and let's see what you got. Okay, let's go ahead and take a look at that. And again, it's a square hole, which is very very handy, very good to know. Okay, it's square, therefore the sides are going to be the same. Okay, so the measurements that we are interested in are the 4 by 4 hole here, 4 by 4 hole, and the 12 inches in height. Okay, so those 3 measurements are going to help us out a lot. All right, so we go ahead and we can see this 4 by 4 hole right there. Now, what we need to pay attention to is the fact that there are walls that are going to be made or created inside of this cube. Okay, these walls are down in there, and there are 4 walls. 4 walls are going to be created, and they're all going to be the same, have the same dimensions, because we are drilling or jigsawing a square hole. Okay. So we have 4 by 12 walls that are going to be created inside of this cube. Therefore, this is a positive here. We are gaining that much surface area, which is quite an interesting thing and a great question to ask. Oh, you cut a hole in something, you gain surface area. It just seems kind of what we call counterintuitive, kind of counter to what you might expect. But we'll talk in a little bit about, well, I think we might have talked about it last lesson, this idea of the sponge and how that sponge, the holes in the sponge and the walls that are created, you gain surface area that way. Okay, so in this case we've gained 192 square inches. So at this point we are up to 1,056 square inches of surface area in B. But what we also need to do is we need to account for the surface area that we lose. Okay, so in our original picture up here, this top here, this was just nice, and this is all surface area here. Okay, you can paint that entire thing. But now down in our new shape here, with our hole cut out of it, we're going to be losing a little bit there. Okay, so we're losing 2, looks like 4 by 4 sections. Okay, and so there we have to account for the fact that we're actually going to lose some surface area. So we're going to lose 32 square inches, and if we take that away from 1,056, we end up with a total. So the total surface area of B is 1,024 square inches, and hopefully you arrived at the same answer. Okay, so here we go. Now we have a problem that I want to tell you about. That problem we just did. A similar problem is going to come up later on in this lesson, and I'm going to skip going through the entire process. So if you didn't go through that process with me in your binder, I'd like you to do that, because this way you'll have something to follow, or an example to follow when you do that that next problem, okay? And this example 2 here as well, I mean, it's example 3 that we're about to do. A problem very, very similar to this one will also occur. So if you take good notes here, you'll be able to use those when you're completing the example that you will see coming up, okay? So here, let's go example 3. Example 3 says a right rectangular pyramid has a square base with a side length of 10 inches, okay? And the surface area of the pyramid is 260 inches squared, okay? Now we want to find the height of the 4 lateral triangular faces, okay? So that is the only measurement we need as our answer, okay? Of course, we're going to need to do other things to get that answer, but as far as an answer is concerned, that you need to pay attention to the fact that that is what is being asked, nothing else, okay? Nothing else is being asked as an answer. So at the end, we're going to have height equals whatever. In this case, it'll be inches, such and such inches, and actually we'll be using a little bit of algebra in this one, as you can imagine. Okay. All right, so what do we know? Okay, we could start out here what we know. What we know is the surface area of the prism is 260 square inches. Okay, we've been given that this square-based prism is 260 square inches. Okay, we also know the area of the base. Okay, we know the area of the base. They haven't given it to us, but they've given us a very important piece of information, of course, because they've told us that the square base has a side length of 10 inches. Okay, therefore it's square. They're all the same. Therefore, the base is going to be 10 times 10, the area of the base. Therefore, that area of the base is 100 square inches. Okay, and then we know the area of the 4 faces is going to be what's left over. Okay, so these are all the things we know here. We know, based on what they told us, we figured this. Okay, we calculated this one as well. Calculated a few using what was given to us, all right? So the area of the 4 faces is 160 square inches. Based on that, we therefore know the area of each face, because there are 4, is 40 square inches. Okay, so at this point, now we can create our equation. Okay, now we can create our equation to figure out the height. Okay, and here's how we do it. All right, so 40 square inches. Okay, that's the area of each face. Each face is a triangle. Okay, it's a triangular face, which was told to us here, it's given to us. Therefore, the area of a triangular face, of course, is going to be 1/2, okay, base times height. Okay, 1/2 base times height. Now, what we have is we have the 1/2. In my equation here, I have 1/2. That's what the 1/2 stands for. Okay, 10 inches is the base, all right, because we were given that up here. All right, 10 inches. And now all we need is the height of the triangle. Okay, and that's why the height is being represented by the little letter h. Therefore, that is our variable, or that is our unknown in this case, okay? So now all we need to do is use our algebraic skills, okay, and figure this out. All right, I didn't want to do that second part. Let me just get those out of the way here. Just 1 second. Let's do one part at a time. Okay, so what we have now is 40 square inches equals 5 inches times h, okay, because I've already taken care of that 1/2 times the base. Okay, because those are the numbers that I have. So I have 5 inches times the height, okay? And of course, you know, multiplying these two by each other is going to give us an answer in square inches. Okay, that's why we have square inches on the left. Anytime you measure inches times inches, you're going to get square inches, okay? We're talking in terms of area, okay? So, therefore, I'm trying to isolate my h, okay? I'm trying to isolate it. Therefore, I want to get that 5 inches, turn that into 1, okay? And what I do is I divide it by its reciprocal, or its multiplicative inverse, okay, which is 1/5 inches. So actually divide it by 5 inches here. You can see that. That's going to give me h, of course. I have to do the same thing over here. So now I'm actually dividing square inches by inches, okay? And when I do that, I will actually get an answer in inches, okay? Because when you multiply inches times inches, you get square inches, all right? Therefore, when I put that 5 inches underneath this 40 square inches, my answer will be in simple inches, which would be 8. So 8 inches equals h, which means the height is 8 inches. Okay, the height is 8 inches. And if we went ahead and plugged that in, okay, into our formula here, 1/2 10 times 8, okay, and right here, so 10 times 8 is 80, and 1/2 of 80 equals 40 inches square, and that is what we have right here. Okay, so that checks out. Okay. All right, so here we go. Let's keep plugging along here. Is our next exercise. So you're going to determine the surface area of each figure. Okay, so now we're going to have a series of figures. How many do we have here? I'm going to flip all the way to the end. And I think we end up having 8 different figures. But like I said before, a couple of these we're going to leave alone, and I'm just going to give you the answers because they are very, very, very similar to ones we've already done in this lesson. Okay? Try to keep this lesson as brief as possible. All right? So let's go ahead and do this one. Well, actually, I'm going to pause and you go ahead and give this a whirl and come on back. Okay, so this one's interesting because it's going to show us something that will come in handy later on. Again, in another lesson, another exercise later on. But it talks about this idea of perspective, looking at something from a perspective here. Okay, so the first measurement here I wanted to talk about were the top and bottom. Right, the top and bottom of this. Now, the top and bottom, though you're thinking, look at the top of this C on its side, B, okay? Well, that top, I'm thinking here, if I'm looking, and we did this in an earlier lesson when we used the blocks, if you remember, the cubes on the graph paper, where we looked at these three-dimensional shapes from different perspectives. And you can see if I'm looking this way at this figure, okay, from the top here, here's my eyeball, okay, here's my eyeball looking down, okay, at this, you would see the top as those 3 portions, okay, those 3 portions I've highlighted in yellow, okay. They could, I mean, if you got in the right angle, they could look like one flat piece actually. And then the bottom, of course, is going to be exactly the same. Okay, exactly the same. Therefore, the top and bottom are 2 times 18 times 5. Okay, because those are what we have, and those are in meters. Looks like meters squared. So we have 180 meters squared for both of those, both the top and the bottom. Okay. All right, so now we have these extra interior sides, okay, that have been created. Actually, you know, if you think about, a piece has been lopped off of this in the middle there, and they've actually created these extra interior sides, and those are there and there, okay, and those are 2 times 5 times 7, and that's 70 meters squared. All right, and then we have the left and right sides, okay, which are easy enough. It's that one and the one over there. Okay, of course, with these two-dimensional depictions of three-dimensional figures, there's always one side, one side in the pair that you can't see, and that's 2 times 5 times 12, and that equals 120 meters squared. And then finally, we have the front and back. Okay, and there's a couple of ways. I'm not sure which way you did it. I chose to decompose here. I took that apart and I created 3 different rectangles two of which are the same on each side. Therefore, I had 4 5 by 12s, okay? 4 5 by 12s, as you can see right there. And then I had right there and there, okay? Those two in the front and then the two in the back. So 4 of those, and then 2 8 by 5s, okay? And those 8 by 5s, you can see right there, they were created. I had to do a little subtraction to figure out the 8 and the 5, but that is not a big deal. All right, so therefore, I figured all that up. So my front and back came to a grand total of 320 meters squared. All I need to do now is add all of that surface area up, and I get my total, which is 690 meters squared. Okay, and hopefully you came to that same conclusion. All right, here is another. It's number 2 here. In addition to your calculation here, now they want us to explain how the surface area of this figure was determined, okay? And I'm not exactly sure what they mean, but here's the way I interpreted it. The way I looked at this was that I am looking at 2 trapezoids, okay, and 4 rectangles, okay? So that is the way I determined it, and well, I'm about to determine it, and I didn't give you a chance to decide how you would determine it, but if you want to, you could do it the same. But if you do it differently, just explain it differently and how you're doing it. So if you would go ahead now and, again, remember this area of a trapezoid, okay, and I'll just give you a hint. Look at this trapezoid as these two, this being the base and this being the top, quote-unquote, base or top. If you remember the area of a trapezoid, you can go back in your binder. It's always good to go look. I'd rather not tell you here. It gives you a chance to go back and look in lesson 23 when we did an area of a trapezoid. Okay, but my one hint, though, very important hint, is use those 2 yellow lines there as your quote-unquote base numbers. Okay. All right, so go ahead and do that. Struggle with it a little bit. That's fine, and come on back. Every breaking wave. Then it's just, they don't give you any. Isn't anybody writing right now? Europe. Yeah, look at that. This mark. Yeah. Europe was. Oh. Okay, let's take a look at this now. See what you can see what I did and check it against what you did. Okay, so let's go ahead and begin. And we have our 2 trapezoids. Okay, so I wanted to deal with those two trapezoids first. All right, and then here again is my formula for a trapezoid. Okay, and again it was, remember, it's half, and then the 2 bases. This is 23 and the 16. Actually, I think I do actually write that in there. Yeah, so the 23 and the 16. That's what those are, and then you're going to multiply that total by 24, which of course is the height. Okay, so it's 1/2 the 2 bases, a plus b. We often say a base plus b base times the height. Okay, and hopefully you got that, and you maybe look back in your notes. So that is going to be 2 times 468, which is 936 square centimeters. Those 2 trapezoids. Okay. Okay, so now we're going to look at these rectangles one at a time, okay, because they're all different dimensions. We have a 16 by 8 rectangle there. Then we have a 25 by 8 rectangle there. Actually, they all have 8 in common, it seems. And then we have a 23 by 8 rectangle in the back. And then we have a 24 by 8 rectangle underneath. All right, so if we add all these up, we get 128 plus 200 plus 184 plus 192. okay, which all equals 704 square centimeters. All right, so all of our rectangles together total up to 704 square centimeters. We add those to the area, the surface area of our two trapezoids and then our four rectangles, and we come up with a total of 1,640 square centimeters. Okay? All right, well, this next one is number 3, as promised, is exactly the same. I mean, the numbers aren't the same, okay? Oh boy, but very, very similar, okay? Same as example 1. So what I'm going to do only here, I'm not going to go through the whole rigmarole again of how we did it, because I'd be saying exactly the same thing as I did with example 1, but I will give you the answer, and the answer to this is 878 square inches, okay? Well, I should have let you do it first. Oh well. Anyhow, here we go. Again, we have another one. This one's a little bit different, okay? So again, they want you to, in addition to the calculation, explain how the surface area was determined, okay? So why don't you go ahead and do that first, decide how you're going to do it, what you're going to, what plus what plus what, and then go ahead and do your calculations and using what you have here, and come on back and check it with mine. Alrighty, so let's take a look. So I see 1 square base, 4 rectangular sides, and 4 triangular roof sections. Okay, so that's how I'm explaining how I'm getting the surface area, by taking this apart, this figure apart in this way. All right, so not sure how you did it. Most likely the same, I'm thinking. So let's go ahead and start with that square base, and that square base, very simply, is 9 times 9, 9 feet times 9 feet, which gives us 81 square feet. Let's go ahead and deal with the 4 rectangular sides, which are all similar. So we have 4 of those, and they're all 9 by 5. So a total gives us a total of 180 square feet. Okay, that 1 right there is looking kind of funky. 180. Oh my gosh, hold on. 180 square feet. Okay. And then let's deal with those 4 triangular roof sections. Okay. Which again are all the same. And you can see we have a base of 9, and then we have a height of 6. Therefore we have 4 1/2 times 6 times 9, okay, 1/2, 4 of those, 4 1/2 base times height, which is 1/2 times 6 times 9, so that equals a total of 108 square feet. Add them all up, and we get a grand total of 369 square feet of surface area in that house, okay? Alrighty, here we go. We have another one here. A hexagonal prism has the following base and has a height of 8 units. Okay. Oh, sorry, I want to stop that for a second. Just want to show you something here. This is going to turn out to be wonky anyway, so I'm not even going to ask you to go ahead and do this one. I just want you to follow along with me, so don't quite worry about this one. Actually, never come to a conclusion, but this idea of height of 8 units. Now, this is real interesting because this is the only thing, we're going to learn something from this, but not exactly what was probably intended. But now, when you say it's a hexagonal prism, if you remember from a long, long time ago, whatever the prism is called, okay, that is the base. Okay, that is the base. So this hexagon you see right here, which you're going to see later, is a little bit wonky. It's a hexagon though, it's 6-sided figure, all right? That is the base, okay? And then we have another one on the other side, and that's the base because the prism is called the hexagonal prism, all right? And whatever the prism is called, that's the base, all right? Therefore, that's why this is important. It says it has a height of 8 units, okay? If you look here on this hexagon in front of you here, there's nothing, there's no measurement here that is 8 units anywhere, okay? The 5 and 4 and 12, all right? So that is not the height. The height is actually, let me go ahead and now draw this picture, okay? All right, so there are my 2 hexagons that I've outlined in purple. Now the height is going to be this these lines right here. These are going to be the height. These all here. Okay, so the way I described this little building here is 1 square base, 4 rectangular sides, 4 triangular roof sections. Okay, and you might have done it the same way. And so let's go ahead and get right to it. So let's go ahead and take care of that square base first. Real easy. 9 by 9, 81 square feet. Okay, and now let's look at the rectangular sides. And those rectangular sides are very simple as well because they are all the same. 4 of them, 4 9 by 5s, gives us 180 square feet total right there. Okay, fix my 1 here. And then, okay, there we go. And then we have our 4 triangular roof sections, which are, again, all the same. Okay, they have a base of 9 feet and then a height of 6 feet that is given to us. Therefore, we have 4 of those. So 4, 1/2 times 6 times 9 gives us 108 square feet. All right, add them all up, and we end up with 369 square feet. Okay. All right, so this next problem here, a hexagonal prism has the following base and a height of 8 units. Determine the surface area of the prism. Now, this is going to turn out to be a wonky problem, which we will not actually get an answer to. Therefore, I don't want you to go ahead and go off and try to solve it. So I just want you to follow along with me here. Because there's a really important part. There's always something to learn, right? But the fact that this is called a hexagonal prism, okay, it has that name. Now, the name of the prism refers to the base, okay? Therefore, this hexagon here, okay, an irregular hexagon, okay, not regular at all, okay, again, a regular hexagon, very easy to work with because all of the sides are the same length, okay, the same measurement. In this case, it's not the case. It's an irregular hexagon. But that is the base, okay? And why I emphasize that is because what they've also given us here is they've given us this height, okay? It's a height of 8 units. So, in fact, this thing should be turned that way, whereas this would be on top and bottom, okay? But let's take a look at, let me get rid of all these. These are all new stuff, so we'll go here. Okay, so here we go. I'm drawing the picture of what this would look like. Okay, so you can see outlined in purple. There are my two bases. Okay, because it's a hexagonal prism. Therefore, those are my bases. What's really important now are all of the. Whoops, didn't mean to do that. I want to go back and. Sorry. Pause. Okay, so these lines that I'm drawing right now, which are going to disappear, actually I could do it this way here. Okay, so all of these lines here that I'm drawing, those are all the 8 unit height pieces. Okay, so in fact, that whole thing, like I had mentioned before, should be flipped over if we really want the hexagon to be the quote-unquote base. Okay, so that is the important part because that's confusing otherwise. If we do see something in the future where it has a height of 8 units, I mean, because if you looked at this here, if you looked at just the hexagon they gave us, there's nowhere was there anything that was 8. Okay, and you're thinking height, and when you think of height, you're thinking up and down. Okay, so that is so that is that. But let's go ahead and get rid of all of that and start working on this problem and show you where it all falls apart. Okay. All right. So if we looked at the area of the bases, okay, and again, this is a base right here. We have 2 of them. We can we can look at this, and because it's not a regular hexagon, we can go ahead and decompose this thing, okay, into parts. There's one rectangle, okay. All right, and that rectangle right there is 12 by 4. Therefore, it is 48 square units. Okay, so that piece right there. And now we can break that next one. We could break up top there to a 5 by 4 rectangle, which gives us 20 square units. And we have the triangle to the left there is nice. It's a 4 by 3, but of course we need to take half of it because it is a triangle. So half of 12 is 6, so there's 6 square units. But here's where it all falls apart. Right there, that little 4 by whatever section there is actually not a triangle. Okay, so it kind of falls apart right there. So we are going to call that one we're going to call that a bit wonky. Okay, so we're not going to do that because we don't feel like it, because I don't want it to be a hassle. Okay, the answer in the book actually treats it like it was a full triangle because they call that 20 square units, whereas we can see that it is not going to be 20 square units. Couldn't actually be. Okay, and actually no, it said it was 10 square units. That's right. Okay, but it would never work out to be that way. So we're going to skip that one, and we're going to move on. Okay, here we go. We're moving on to this one here. This next one, of course. Boy, these two look really, really familiar, don't they? So we are calling this same idea as example 2. All right, this A and B here, they are the same idea. Okay, and again, like I said before, I'll only give you the answers here. So the answer to this one, this cube, very, very simple. Just a bunch of 6 9 by 9 sides or faces gives us a total of 864 square inches. B, the answer, again, this is the same as we saw before, okay, in example 2. And the answer, just adding and subtracting as you need to with that new hole. And the answer here was the surface area was 1,024 square inches, and you can see that was a gain of 160 square inch gain there. Okay. All right, but now this one's a little different. Okay, and this is fun, real interesting. Now we have this one, a second square hole with 3 meter side lengths has been drilled or jigsawed through the cube. Okay. So let's. Why don't you go ahead and give that one a whirl? Just make sure you're paying attention to all the places where you're going to gain surface area and lose surface area, because this gets a little tricky and gets a little hard to keep track of. So make sure you draw some lines, okay, to create your 3-dimensional holes through this cube to help you out. Okay, so go ahead. I'm going to pause here and go ahead and give that a whirl. Okay, so let's take a look at this one. All right, so from part B, okay, we know we have our surface area of 576 square meters. Okay, so I can start right from there, and that's, part B was just that one hole that was drilled down through the top to the bottom. Okay, so I have that. All right, now I need to subtract what I am losing in surface area. Okay, so when this second hole was drilled, okay, this is the easy part. This I lost these 3 by 3 meter squares. Okay, but what I also lost came from inside this cube. If you think about it, I'm going to try to draw this 3-dimensionally here to make this make sense. Okay, inside of this cube, okay, there are the walls that I created. In part B, we created the walls here. Okay, now those walls have actually been dug through. Okay, they've been drilled through. So these little pieces, little purple pieces that are represented by purple there, we actually lost that surface area as well. Okay, we lost that as well, and that might have been one that you might have missed. Okay, but all of those, all four of those pieces that were removed are all the same, which is nice and handy. So we just multiply 4 times 3 times 3. So what we did is we lost a total of 24 square meters in surface area with that hole drilling. Okay, but we also added some. Okay, because we drilled another hole, and of course we're always going to add some surface area if we're drilling through a solid. Okay, so let's get all that out of the way, and let's draw this representation again. And this is probably the best representation I've created yet. Okay, and you can see I've created the two holes there. And what I'm going to do is I'm going to highlight those parts that I have added. Okay, and those are all as well 3 by 3. They don't look 3 by 3 there, but they are all 3 by 3 because it's 9. We have 9 meters across here. Okay, so each one of these pieces, 1, 2, 3. Each one of those is 3 meters. Okay, so we have 1, 2, 3, 4. All right, and then 5, 6, 7, 8. We have 8 of those. 8 of those sections, 3 by 3 sections that we are actually gaining. Okay, so we're gaining that surface area. So here we go. We started out with 576 square meters, and then we added 48 square meters for a total of 624 square meters. But we have to now pay attention to what we subtracted. So we subtracted away 24 square meters, and what we end up in the end with is 600 square meters of surface area. Okay, and that one might have been the most challenging yet. I'm hoping you are able to see more clearly these little intricacies and the things to look for, and how drawing a picture, this three-dimensional depiction of two-dimensional depiction of a three-dimensional figure, and how that can help you out as well. Okay, let's move on. All right, here we go. This is similar to one we saw before. The other one was was a very, very simple version, but this one is probably simpler than you think. So what I'd like you to do is go ahead and struggle with this yourself here. The figure below shows 28 cubes with an edge length of 1 unit. Okay, find the surface area. So each of those edge lengths of all those 28 cubes are going to be 1 unit. All right, so go ahead. I'm going to pause here. You pause and go ahead and struggle with that, or maybe you'll find the simple way to do it. All right, so let's go ahead and take a look at this one. All right, so firstly, the area of the top and the bottom. Now, I put top in quotation marks because, again, it's a perspective idea. Okay, all of those yellow areas, and there's my little eyeball looking down, that is what I see as the quote-unquote top of this figure. Okay, and it's so interesting. The surface area, what you'll come to see at the end of this is if you had actually built up some of these areas, not this one right here, but if you had built up all these areas here, you really wouldn't lose or gain any surface area. Okay, and we'll see here why. Okay, so there is my top, and of course my bottom is underneath there, and it is perfectly it's 4 by 4. All right, so therefore my 4 by 3. So we have 4 by 3, and then we have, you can see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so both of those are 12. Therefore we have our top and bottom equal up to 24 square units. Okay. Next, we have the area of our quote-unquote sides. Again, very atypical sides in this sense. When you think of side, you think of something a flat side, but again, thinking perspective-wise. All right, and there we go. There is our side, and now I have my little eyeball here, looking this way. Okay, at the figure. All right, and there would be my side, and on the other side, it's also going to be similar. Okay, both of those are 9 units squared. Okay, 9 square units. So we have 1, 2, 3, 4, 5, 7, 8, 9. And then on the other side, we would have this 3 by 2 on that other side. So that's 6. And then we'd have this one down here, which is 1 by 3. Okay, and that's 3. And of course, that's 9. All right. Okay, so each one of those is 9 square units, and therefore we have 18 square units for the sides. Okay. Next we have the area front and back. Put those two in quotes as well. Front and back. Again, we're looking our eyes, and we're looking this way right now at it. Okay, staring that way, and then from there as well. Okay, and those two. Okay, going to be right there. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. So we have 14 square units there, and then 14 in the back, and for a total of 28 square units. All right, add those all together, and we have a surface area. These 28 cubes piled up the way they are would give us an area of 70 square units. Okay, so one more to go here, and this one, actually there's not one more, I think there's a couple more, but anyway, this one, the base rectangle of a right rectangle of the prism is 4 by 6. The surface area is 288 square feet. Find the height. Boy, that sounds really familiar. Same idea as example 3. If you remember, we had to create an equation to find the height, and I'm just going to go ahead and give you the answer. And the answer to this one, if you go ahead and work it out, is the height equals 12 feet. And I did it again. I didn't give you a chance to pause. Sorry, hopefully you paused, or maybe you want to just go ahead and do it and see if you get that answer, 12 feet. All right, so here we are. That was the last one. Actually, we are here, lesson summary. Okay, in summary. To calculate the surface area of a composite figure, determine the surface area of each prism separately and add them together. From the sum, subtract the area of the section that were covered by another prism. We saw that happen a couple of times. And then to calculate the surface area with a missing section, find the total surface area of the whole figure. From the total surface area, subtract the area of the missing parts, and then add the area of the lateral faces of the cut-out prism. Again, just like we did over and over again, adding what your new surface area and subtracting out the surface area you lost. Okay, so go ahead, good luck with your problem sets. Hope there are not too many there. I'm not going to look because I'm afraid. Anyway, that is the end of lesson 24 on surface area. We will tackle some new material next. It looks like lesson 25 is volume, and then 26 is volume, and then 27 is volume. So we're going to finish up with a bunch of volume problems, okay? Anyway, good luck with that, and see you next lesson.